Hello everyone. So I will start to give you what you're gonna do in the exam. Okay, so firstly you're gonna basically go to week number 5. Now in week number 5 you will see a few topics over here. So you will see the midterm pretest, you will see the midterm exam, and finally you will see the midterm pretest. After downloading your files, so you can start your exam. Now there is a PDF format for the exam and there is Word. So make sure you send me an email when you start the exam. And after you finish the exam, after reviewing your all answers, please send me another email. Now, to begin with, read the instruction carefully. So, this is an online exam. Although you have access to the online material, I would appreciate if you just work while your laptop is in a flight mode. Well, if you want to use something, please at least cite it for me. So the exam supposed to be starting from 3:35 and ends at 5:40. Okay. It shouldn't take that much time, so you can solve it in less time. Now the exam will be included in three parts, similar to the what you have seen in the pre-test, but instead of having 25 multiple choice questions, you have only 20. Now we have the second question, which is the calculation for the area or a situation using Monte Carlo simulation, and the third part will be basically doing a Markov chain analysis. Now read out the multiple choices very carefully. So you will see that there is a questions built upon previous information, and there is a questions will be standalone question. So for example, the question one says Monte Carlo simulation is a tool considering the, so we have a multiple choices. You're gonna pick what the correct answer from the following. Now in a question 2, 3, and 4, you need to go back to this information. Okay, so it's asking you what kind of distribution the information described as we taken from the lecture. The second questions goes etc., etc., etc. Now, make sure basically you're using the information given from each part separately. Okay. Now it says question number 5 and 7. So we have 5 and 6 and 7 follows the information given above. Now you might be having another information. So in the first part, we're gonna try to model after the given information. Now I can tell some of you could be taking the wrong answer. So to fix that, we have given information to make sure everyone gets the answer. Now, the other thing here is I want you to make sure you can do it if like you haven't seen any of the answers are correct. So please write me down the right answer and how you have calculated. So maybe I may miss something or maybe you like get another way to solve it. So let's see. Now there is a very important thing for question number 19. So in the question number 19, uh, I want you to use the last four numbers from the student ID, and I have them. So the answer should for each individual, unless you have the exact four last numbers, so you will have the same answer. Otherwise, so each student will be get a different answer giving that information. So when you're calculating this kind of thing, so each one of you will get a unique answer. So most of you will do a D. So make sure you solve this problem based on your ID number. So it could be 214 as an example, or it could be different. Okay. And of course, I gonna be see based on your real ID number. So I have them, and I can basically grade them on that basis. Now we're starting with the first essay question, which is counts for 20%, while all the multiple choice count for 60%, where each multiple is 3 points. So we have given information that we have um, a rectangular, and we want to calculate basically the semicircle which is enclosed within this rectangle. Now there is an equation here. Okay, this equation is like assuming the rectangle and the circle sharing basically the same diameter here and the length for the rectangle. And well, the area, the proven area for the semicircle is 2 pi, which is 6.24. Okay. So I want you to generate a simulation for 100 points, and then basically generate another simulation using 1000 points, and try to compare it with whatever solution you got here. You can use an Excel as we done in the lecture. You can use Python, you can use MATLAB or RStudio as you wish, as you please. But please, whatever software you're using, upload the script or the sheet that basically give you the final answer. Now the last question is basically another essay, but this time for Markovian analysis. So you're gonna basically start drawing the transition matrix and the initial state, and also so you're gonna draw the transition matrix and the initial state. Okay. Now the second one, basically taken in these scenarios, we want to see what is the probability that customer will be AV after one transition, like after 1 year, meaning, or they're gonna be a hybrid after 2 years. Finally, we will see if they're gonna be sticking with a gas after 3 years. Now, after that, I want you to see if the market will be saturated or the market will be reach a steady state, which is called a stationary state. So I want you to determine it. Of course, we learn how to determine the eigenvalues for this question. Now, this is not very hard question. This is usually, it's only taken 1% for the whole exam. But I want to basically disconnect between the students who could answer it or not. So regardless if the basically the matrix will be reaching the stationary state or not. Let's assume the car was banned after 10 years. Okay, so let's assume like your market share goes either EV and plug-in, and all the customer will be distributed equally. So whatever have gas car, so whatever percentage was originally for EV, what percentage originally was plug-in hybrid, so they will basically take the customers from there. So how is the market share will look like? Okay, so you're gonna expect how basically this is gonna be like us after 10 years from now, especially if some states already have a legislation to forbid the gas cars. Okay, it should be very easy exam. And if you have any question, just throw an email to me. But again, when you start the exam, please send me an email. When we finish it, send me another email. And good luck with your exam.